So now we have geometric sequences. So geometric sequences are pretty close to the same thing as arithmetic, except now when we're finding our common, it's called a common ratio. Because instead of a common difference, where we're adding or subtracting the same number each time, a common ratio means that we are multiplying by something each time. We still have a recursive, meaning recursive means we had to use our previous term to figure out our next term. So our common ratio, previous term times whatever number that is, gives us the next term, or our explicit. So meaning it doesn't matter if I was looking for the 150th term, as long as I know my ratio and what I'm looking for, I can figure out in my first term, I can figure out what the number would be. So first we have to identify that geometric sequence. So to determine if it's a geometric sequence, you have to check to see if you're multiplying by the same thing each time. So here I would be multiplying times 2. Here I would multiply times 2. Here I would multiply by times 2. So yes, this is going to be a geometric sequence. It's asking for what's my first term. My first term here is 3. And my common ratio, my r, whatever number I multiply by, is 2. So here I multiply by 2. Here I'm multiplying by not 2. So right away, this is a no, because I'm not multiplying by the same number each time. Here, if I'm looking at this, from one to the other, I could be multiplying by 3 to the 5th. Here, if I multiply from one to the other, I can multiply 3 to the 5th. Because remember, when you're multiplying, you're adding your exponents. So 5 plus 5 would give me 10. 10 plus 5 would give me 15. And I still have 3 to the 5th. So my first term is 3 to the 5th, because that's this A1. And my common ratio is 3 to the 5th. If you also want to write it out as 3 raised to the 5th, that's the same thing as 243. So you're multiplying by 243 each time. So I want you to pause the video and try D, E, and F. So this is yes, my first ratio is, or my first term is 2, and I'm multiplying by 2 each time, so my common ratio is also 2. Here I'm not multiplying by the same thing, so no, that is not a geometric sequence. Here, my first term is 2 to the 3rd, or 8. And each time I multiply by 2 to the 4th, because again, you're adding your exponents when you're multiplying. You're adding your exponents when you're multiplying. So now we want to look for the 10th term. This is where we want to use our explicit formula. So if I'm looking for a to the 10th, so again, I'm filling this out, a to the 10th is equal to, I know that my r value, this would be times 3 times 3. So r is equal to 3. My a to the first is equal to 4. And my n value is whatever number you're looking for. I'm looking for my 10th term. So in this case, my a to the 1 is 4 times my r here is 3 raised to the power. So this is raised to the power of 10 minus 1. Plug that into your calculator. A lot of times people get confused. I would personally just go 3 raised to the 9th power instead of 10 minus 1. So my 10th term in this sequence is 78,732. I want you to pause the video and try to do B by yourself. Kidding. I didn't realize that we didn't have another example problem. So just like we did before, my a to the first is equal to 2. My a to the second, we don't know. My a to the third, we don't know. And my a to the fourth is equal to negative 54. We can set up an equation for this, because remember, you're multiplying by r, you're multiplying by r, you're multiplying by r. Now, when I'm doing this, once you get used to it, that's fine. But I can have my negative 54, because that's my fourth term, would be 2, because that's where I'm starting from, times r, times r, times r, because you're timesing by r 3 times. Or because you're timesing by r 3 times, this is the same thing as negative 54, 2 raised to the r cubed. So if I solve this, I first divide by 2, so I have negative 27 is equal to r cubed. And then to get rid of something cubed, I have to take the cubic root. And I can take the cubic root of a negative. The cubic root of negative 27 will give me negative 3. So r is equal to negative 3. So if I do 2 times r, so my a2 will be equal to negative 6. And then that times negative 3 would give me a positive 18. So my a2 is negative 6, a3 is 18. Pause the video and try to do C. Your A2 is equal to 6. So another way you could have done this is whenever you have your missing number, like here, we have our geometric mean also. We have our arithmetic mean, where we found the average. For our geometric mean, we have a positive, negative, and that depending on if it's going to be positive, negative. So technically, this right here, because we don't know if R is positive or negative, this should be a positive, negative number. Because if R was a -2, then that would give me a -6. If R was a +2, that gives me a +6. So my geometric mean is positive, negative the square root of x squared. So if I want to solve this, it's the same thing that we did here with our equations, but now when you just have one missing number, we can do 48 times 3 and take the square root of that, but you're going to have a positive, negative number. So again, right here, when I was solving, this is where that positive, -2 comes from, because you're not sure if it's positive or negative. So if you do the square root, 48, this would give you a positive, -12. So when I'm using my geometric mean, I am not finding R. Again, this is the middle term. Positive, -12 is my middle term, and it's not the R value. Pause and do B by yourself. You should have gotten positive, -60. Bing, bada, boom. There you go. Have a great, grand, wonderful day.